All right, Algebra 2, let's begin. Sorry, that was the paper moving, not anything weird. Let's go through our review sheet. All right, so question 1 says, is the relationship between the variables in the table inverse variation? Well, recall that to determine inverse variation, we just need to make sure that x times y equals the same constant. So 1 times 50, 50. 2 times 25, 50. 4 times 12.5, 50. 5 times 10, 50. 50, 50. So all of these are indeed 50. So that means that our k is 50. And the way that we write this equation is y equals rk over x. So there is our final answer for number 1. For number 2, I'm going to go through 6.6. I don't know why that does that. Let me try this again. 6.6, 11. Oh, no inverse variation. Big old fat no. Okay, question 3 says, suppose x and y vary inversely. So that means that we know that y equals k over x. It says at x equals 11, y is 5. So I'm going to have 5 equals 11, and we need to figure out what our k is. So when we multiply both sides by 11, we get that k is 55. And that means that our equation for this one is y equals 55 over x. That's number 3. Number 4, a softball team is collecting money to buy their coach a present. The table represents the cost per person for the gift compared to the number of people contributing. Okay, first things first. What function models the data, and how much per person will the cost of all how much per person will it cost if all 30 players contribute? This is inverse variation because, of course, the gift has a constant price, and the more players that give money, the cheaper the gift's going to be. So let's figure out what that constant price is. It is 150, 150, 150. I need to be a softball coach to get a $150 gift. So we know then that our function is going to be y equals, oh, wait, nope, we can't use y because they gave us variables. So c, the cost per player, and n is our number of players. So we're going to say that c, the cost per player, is equal to our constant of variation, or 50, over our number of players. So there's our function. And then if we have all 30 players contributing, then we would just plug in C for N. Sorry, I'm trying to keep this all color-coded for you. I'm going green, y'all. So C is going to be $5 per player. Okay, the next question starts talking about our translations on our inverse function. So this is our parent function in this case. Notice that there's a 4 on top, not a 1. Now we need to determine our x and y shifts. So I'm going to start out by having y equals 4, and then our x stays there on the bottom. First is our horizontal shift, which went over to -4. So that means we change it to the opposite and we add it. So +4. Then our vertical shift went up 3, right? Is that at 3? Yep. So we're going to do +3. Okay. Number 6. Find the horizontal asymptote. Remember that horizontal asymptotes deal only with the first, with the power of the polynomial. This polynomial is top heavy, meaning that exponent, I'm going to zoom in, that exponent right there, oh my gosh, why is it doing that? That exponent there is bigger than the exponent on the bottom. So there are no horizontal asymptotes. Okay, for number 7, we look and I'm going to zoom in. We have a squared on top and a squared on the bottom. So when they're the same, we then look at the, I'm trying to change the color of my highlighter, y'all. It's not working. Here we go. We look at our leading coefficients. So for this one, our horizontal asymptote is going to be y equals negative 3/2. Now, question 8 says, what are all of the asymptotes? The first thing you have to do is factor first. So on top, we have x minus 4, x plus 4 over x plus 5, x plus 1. So to get our vertical asymptotes, we're going to set the bottom equal to 0. So x plus 5 equals 0, x plus 1 equals 0. So if x equals negative 5 and x equals negative 1. So vertical asymptotes are at x equals 5, negative 5, and x equals negative 1. Then we go back to our original function, and we can look, they are both squared. So we're going with our coefficients that are out front, which, since there's nothing written there, we can just assume they're 1. So we're going to have a horizontal asymptote at y equals 1. Number 9, identifying the horizontal and vertical asymptotes and then graphing it. So I'll start here with my vertical asymptote is going to be at x, son of a biscuit, x equals 3, and our horizontal asymptote is going to be at y equals 4. So there's our horizontal asymptote, which you should draw it as a dotted line. Here's our vertical asymptote. Then to figure out where each part of the graph lies, if I plug in 0 for x, I get negative 1/3. So 4 times 0 minus 1 over 0 minus 3 is, positive 1/3. The positive 1/3 is still down here below, well below our asymptote at 4. So there's that. Then if I plug in 4 for x, I get 4 times 4 minus 1 over 4 minus 3, which gives me 15 over 1, which is greater than, so greater than 4, or I should say. So that gives me this part up here. Now for number 10. Number 10, we're going to have we need to factor this first because it is not in factored form. So we're going to have 4x squared over 2 times x minus 4 times x plus 4. And so that means that our vertical asymptotes are going to be at x equals 4 and x equals negative 4. And our horizontal asymptote, because these are the same power, is 4 over 2, or 2, so y equals 2. And I'm going to draw these on here, and then we will determine where our graphs go in the next video. So here's a horizontal